Okay, acid-base neutralization. So we've seen neutralization before. Let's say we mix an acid and a base. So let's say we have 2 moles of strong acid, HCl, monoprotic, and let's say we have 3 moles of strong base, sodium hydroxide. Okay, the products are a salt and water. And here's what happens. What we have when we put 2 moles of HCl in is, remember, chlorine is basically like a spectator ion. So really what we have is we have 2 moles of H plus in there. Okay, and then we put sodium hydroxide in there. Okay, so, and remember the NaCl, those are in there too, but they're just spectator ions. So here's what happens. A hydroxide is going to attract an H plus and form water. There's a neutralization reaction. This one, these two, are going to form water, and therefore those neutralize each other. But what we still have is we still have a hydroxide here. Okay, and we actually have 1 mole of hydroxide left over. So then what we could do, if we had the volume, let's say it's 1 liter, what we would do is we'd take the 1 mole of hydroxide and find the molarity, and that means we have 1 molar of hydroxide. Then we could go ahead and take the negative log of that, okay, and find the pOH, and then subtract 14 from that, and that'll give us the pH. So that's essentially what we're going to be doing in these problems. Okay, so just a little refresh. Neutralization reactions, we form a salt and water. That's what we're seeing here. And then what we have down here is another example. What happens when a carbonate is placed in an acid? Well, a carbonate is unique in that it forms carbon dioxide. Okay, so you've seen this with baking soda and vinegar. That's why it's bubbling. It's producing carbon dioxide. So carbonates are great bases, and they're great to use to indicate if there is a presence of an acid. So calcium carbonate is a good example. Seashells, chalk, it's limestone is what it is. So when you drop a seashell into hydrochloric acid, those are the products that you get, and it bubbles because it's producing CO2 gas. Okay, so here's our problem. So just like the previous problem, what happens if we mix 1 mole of NaOH and 1 mole of HCl? Well, if we have 1 mole of each, they're going to cancel each other out and produce water. So that would give us a neutral pH. But what happens when you don't have equal quantities, kind of like our first example? Well, here's our first problem. We have 100 mils of a 0.1 molar H3PO4, and that's a triprotic acid. And it's a strong acid, so we assume 100% ionization. 100 mils of 0.1 molar CaOH2, we assume that's a strong base, so 100% ionization. And so what is the resulting pH? So really what we're looking at is how many moles of H plus do we have? How many moles of hydroxide do we have? Let's cancel out all of the hydroxide and hydrogen ions because they form water, and what's left over, and then let's determine the pH of it. So first step, determine the moles of each. So if we have 0.1 molar, what we're going to do is divide it by 0.1 liters because we have 100 mils. So our molarity formula, molarity equals moles divided by liters, solve for moles. That means we have 0.01 moles of a triprotic acid. Then we do the same thing, and we have 0.01 moles of calcium hydroxide. Okay? So now we need to figure out how many moles of H plus do we have. Well, for each molecule of H3PO4, we produce 3 hydrogens. So what we're going to do is we're going to multiply our concentration of our triprotic acid by 3. Then for calcium hydroxide, it produces 2 hydroxides for every mole of molecule. So we're going to double that one. Okay, so that's going to give us 0.03 up at the top here, and 0.02 right there. So subtract the least from the greatest. Okay, and what we have left over after all of the hydrogen and hydroxide have been completely used up The only thing we have left over is 0.01 moles of acid, H+. So then what you do is, we know moles, so don't forget, we have to find molarity in order to find pH. So that's what we're going to do next, find the pH of the resulting solution. So notice what we're going to do, molarity formula, moles divided by liters. Where did I get 0.2 liters from? Well, if you look in the original problem, what we have here is we mixed 100 mils of acid with 100 mils of base, which gives us 200 milliliters. That's where our 0.2 liters came from. So divide our moles that's left over, and in this case it happens to be the H+, and that means we have a 0.05 molar solution of H+ ions. Now we can go ahead and take the negative log of that, and it gives us our pH. So another type of problem you might have is in this case we had some H+ left over. Well, you might have OH negative left over, in which case you go through the same process. The only thing is when you get to the last step to try to get the pH, if you take the negative log of your base, that's going to give you your POH. Then you just go ahead and subtract it from 14. Okay, so that will conclude our acid-base neutralization lesson.